Okay, so we are picking off, this is Redzone 8B. I'll write that on the screen, 8B. I believe we're picking off right where Mr. Viola left off at 8A. So we're talking about a system of equations. And just to remind you, a system of equations is a set of two or more equations where we are looking for a common solution. So hopefully you guys remember from Unit 2 when we did linear equations that any linear equation has an infinite amount of points on it. Think about when we graphed lines. You start at a point and then you do rise over run and you just keep drawing a bunch of more and more points. So each linear equation has an infinite amount of solutions. But when we give you two equations, we're looking for the one solution that they have in common. Here's an example. So here's an equation, x plus y equals 6. Equals 7. I don't know why I said 6. Can you think of some numbers that I can plug in here that would make this equation true? I'm sure a lot of you, if you actually did this, thought of 6 plus 1. That would be true. So the coordinate 6, 1 is a solution. How about 2 plus 5? That works also. So 2, 5 is another solution. 3 plus 4 is another solution. 1.5 plus 5.5 is another solution. So I can do this forever. You guys can do this forever. So you can see that this equation, x plus y equals 7, has an infinite amount of solutions. Now we know it's a linear equation because when I plug these points onto a graph, they're going to make up a straight line. Now let's look at a second equation. So this equation, x times y equals 12, also has a bunch of different solutions. So hopefully you're thinking of two numbers that when you multiply them together will give you 12, maybe like 2 times 6. So 2 6 is a solution, or 1 times 12. We can get into fractions and decimals. I'm not going to do that. But how about 3 times 4? That works as well. So if you notice, each one of these equations, we can just keep coming up with more and more solutions, but there is only one solution that they have in common, and that would be the point 3, 4. That's what we're looking for when we solve a system of equations. We are looking for the one solution that both equations have in common. One method for solving a system of equations is called graphing. Now in 8th grade, we only have to worry about linear equations, equations that form straight lines. So when we graph them, there's only 3 possibilities. And here are those 3 possibilities. If you get 2 lines that intersect, then that point where they intersect is the solution. So that right there would be the solution. So when you have 2 lines and they intersect, there is one solution. Or you can graph the lines and they are parallel, like here in the middle. Are there any solutions now? Do they have any points in common? No. These lines are never going to touch. So when you have parallel lines, there are no solutions. And sometimes you can tell the lines are parallel just by looking at their equation. So y equals 2x plus 6, y equals 2x minus 4. I wouldn't even have to graph these. Because they have the same slope, I know they're parallel, and therefore I know there's going to be no solution. And then coincident lines, these are 2 lines that when you graph them, fall right on top of each other. It almost looks like there's just one line there. When that happens, there are infinitely many solutions. So again, when the lines intersect, one solution. When you have parallel lines, they will never intersect, so you have no solution. And when you have 2 lines that fall on top of each other, like here in the third graph, you have infinitely many solutions. So now let's talk about another method. So this is the third method that we learned this year for solving system of equations. It's called elimination. Now, elimination is when you add 2 equations together in order for one of the variables to cancel out. So we're not just adding them together for fun. We're adding them together with a purpose. We want one of those variables to cancel out. So in order for that to happen, two things have to be true. One, the equations need to be lined up. And we'll talk about what that means on the next slide. And two, one of the variables has to have opposite coefficients. If you remember, opposites are numbers that are the same distance from 0, like 3 and -3, 5 and -5, 12 and -12. Those are opposites. You need like a 12x and a -12x, a 5y and a -5y. If both variables have opposites, well, that means something else, and we might come to that in this lesson. So let's look at a practice problem. So here's a system of equations, and it tells you to solve it. So remember, we're looking for the coordinate that is a solution to both of these. So we could graph these, but if I wanted to graph them, first I would have to rearrange them into slope-intercept form, and that seems like it's going to be a lot of work. And you got to hope that the numbers work out really nicely, which I'm not even sure if they do. You could do substitution, but they're not in the correct format for that. We don't really have enough information to do substitution the way they're given to you right now. So my first instinct for this is we can solve this using elimination. Remember, elimination is when you add the two equations together so that one of the variables will cancel out. If you look, these two equations are lined up perfectly. What do I mean by that? The x's are on top of each other, the y's are on top of each other, the equal signs are on top of each other, and the constants are on top of each other. These two equations are written in the exact same format. Check. What's the second thing that needs to be true? We need to have a variable that has opposite coefficients. Well, 5x and 2x are not opposites, but positive 2y and negative 2y are opposites. Double check. So now we can start. I'm going to rewrite them over here so I could do some work. So remember that elimination is adding the two equations together in order to cancel out one of the variables. So let's add them together. 5x plus 2x, 7x. Positive 2y, you have to look at the sign. Positive 2y plus negative 2y, that equals 0. That's called the additive inverse property. When you add a term and its opposite, the answer comes out to 0. So I can just cross them out. Equals negative 15 plus negative 6 is negative 21. So now, this is just a one-step equation. To get the x by itself, I divide both sides by 7, and I get x equals negative 3. I look at my choices, and I see that choice A and C both have an x value of negative 3. So I figured out the x value, but I still need to figure out the y value. So in order to do that, I take one of the original equations. It does not matter which one. And I'm going to substitute my x value into that equation. So 5, and now I know x is negative 3 plus 2y equals negative 15. So now I'm going to be able to solve this because it's an equation that only has one variable in it. So negative 15 plus 2y equals negative 15. I'm trying to isolate the y, so the first thing I'm going to do is get rid of this by doing inverse operations. Now I have 2y equals, well, negative 15 plus 15 is 0. And then I divide both sides by 2, and I get y equals 0, choice A. Okay, on to the next one. So I see that we have a system of equations, two equations that are both using x and y as the variables. I can see that they are lined up perfectly, the x's, the y's, the equal signs, the constants, and I can see that we have opposite coefficients. So I'm just going to go ahead and add these together, and I get 3x equals 15. I didn't write anything with the y's because they canceled each other out. Divide both sides by 3, x equals 5. Now I could stop here because if I look at the choices, only one of them has an x value of 5, but I should make sure that it's correct. So I take one of the equations and I rewrite it, but I replace the x with a 5 because I know that x is 5 now. And now I have to solve this equation. So 10 plus 3y equals 6, minus 10 from both sides. 3y equals negative 4. Divide both sides by 3. And I can see that y equals negative 4/3. I didn't actually divide these because I know that 3 doesn't go into 4 evenly. It's just going to give me a repeating decimal. So I left it as a fraction, and I can see that that is what the y value should be. So it's correct. All right, here we go. So this was lesson 4 in Unit 4, and it gave a lot of you some problems because not only do we have to solve a system of equations, first we have to write it. So at a local basketball game, all tickets are the same price, all souvenirs are the same price. Mr. Smith bought 2 tickets and a souvenir. So I'm going to let T equal tickets, and I'm going to let S equal souvenirs. This is called declaring my variables. It's something that when I was in 8th grade in high school, my teachers made us do for every single word problem. You had to tell what the variables are, but we haven't really stressed that, but it's a good idea to do it, especially if you're someone who always uses X and Y. But I'm going to use T and S. So Mr. Smith bought 2 tickets and 1 souvenir. So he bought all that, so we're going to add it together. And it was $17.25. Ms. Lockhart bought 5 tickets and 2 souvenirs for $42.00. I could just write 42. How much was a ticket to the game? Well, this looks like a system of equations to me. We have 2 equations that are using the same variables. So I can think about the methods. I could graph this, but 1, we're not using X and Y. 2, these numbers are not going to work out well. 3, I don't want to rearrange it. We can use substitution, but I would have to do some rearranging. I think this is a good candidate for elimination because the equations are lined up perfectly. However, this time we are missing something. Remember, you need one of the variables to be opposites, and we don't have that. We have 2t and 5t, not opposites, and we have 1s and 2s. So if you remember back in Unit 4, we learned, well actually we learned this a lot earlier, but we relearned it, that you are allowed to change an equation by multiplying the entire equation by a number. So if I want one of the variables to be opposite, I can multiply this entire top equation by something. Well, since this is a 2s, what's the opposite of positive 2s? Negative 2s. So if I multiply the top equation by negative 2, then this part right here will become a negative 2, and that's what we want. So I'm going to multiply this, and I'm going to rewrite it underneath. So I'm going to do the distributive property, making sure I multiply everything by that. So I get negative 4t minus 2s equals negative 34.50. The other equation we didn't touch, so I'm going to leave it exactly the same. Equals 42. Let me just, oops. Just moving it over here, making it smaller. There we go. So now that we have our opposites, we can add this together. Negative 4t plus 5t is 1t, or just t. Negative 2s plus 2s cancels out. And when you add this together, you get 7.50. So t equals 750. That's what we were looking for, the ticket to the game. That's the answer. Here's another system of equations. So when you get to these, you have to decide what's the best method to solve it. I look at this and I think, yep, this sure looks like elimination because everything looks lined up. And neither of the equations are in slope-intercept form. If we're in slope-intercept form, I probably start thinking about graphing our substitution, but we're not. They are lined up, but neither of the variables are opposite. So I need to multiply one of the equations by something. I'm not going to multiply the top equation because that one has the bigger coefficients. It has the 8 and the -2. So I'm going to multiply the bottom equation by something. So if I look at the x's, I see that the top equation has an 8, so I need the bottom equation to be -8. So I need to multiply this by 2. I also could have looked at the y's, but I chose to look at the x's. So now I bring this over here. I didn't touch that. And I bring this over here, but I have to multiply. So -8x plus 2y equals 6. Now when I add them together, something interesting is going to happen here. 8x plus -8x is 0. -2y plus 2y is also 0. So now there's nothing left on this side, so I have to put a 0. Both variables canceled out. And I'm left with this statement, 0 equals 7, which is never true. So if you remember from Unit 1, this tells us that this system of equations has no solution. And if I did want to rearrange both of these into slope-intercept form, the top equation would be y equals 4x minus 1/2. And the bottom equation would be y equals 4x plus 3. And since they have the same slope, we see that they are parallel, so they have no solution. Here's another word problem. So the amount of revenue that Jason receives, that's how much money he's going to make from selling X posters, is given by this equation. The cost of producing the posters to make them is represented by this equation. How many posters does Jason need to sell so that the cost and the revenue are equal? So this goes back to when we used to compare companies, like phone companies, movie plans, renting trucks, and you just need to set them equal to each other in order to solve that, because they want to know when they will be equal. Also, since both equations are in y equals form, you can use substitution and just set them equal to each other. So I just need to solve this equation. I do minus 1/2 x on both sides. That's 3.5x equals 280. And divide by 3.5 on both sides. And I get x equals 80. So choice B. All right, here we go. Two rectangles are shown below. Rectangle P has a perimeter of 20 inches. Rectangle Q has a perimeter of 30 inches. And we need to find the values of J and H. Now, this is a good chance to talk about being a good test taker. This is a tough question that a lot of you got wrong on the Unit 4 test, but they give you the choices. Here are some different reasons that you got it wrong based on when I checked all the work. And this goes for my classes, but this isn't just this year, this is every year, and I'm sure the other teachers would agree. One common mistake that students make when they're dealing with perimeter question is they only add 2 of the sides. That's not what perimeter is. Perimeter, you have to add all 4 of the sides. So that was one mistake. Another mistake students make is they see a rectangle and they see a length and a width and they go, oh, area equals length times width. This question has nothing to do with area, so don't even think about doing that. And then the third reason people get this one wrong is they have no idea what to do because they see the word perimeter, they see shapes, they go, we're doing system of equations, not shapes, and they just guess. But if I was a good test taker, I would take these numbers, I would plug them in, and then just do the perimeter and see if it matches up with the question. But I'm going to show you how to do it mathematically first, then I will show you that way. So perimeter is when you add up all 4 sides, or the perimeter of the rectangle is 2 times the length plus 2 times the width. So for rectangle P, that would be 2 times j plus 4 plus 2 times h. And they tell you that the perimeter equals 20. For rectangle Q, it would be 2 times j plus 1 plus 2 times 3h equals 30. 30 is in the question. So now I can simplify each of these equations a little bit. 2j plus 8 plus 2h equals 20. And if I move the 8 to the other side, I get 2j plus 2h equals 12. And for the other rectangle, I get 2j plus 2 plus 6h equals 30. So that's 2j plus 6h equals 28. So now I have two equations. And the good thing about these two equations, whoops, let me make that a little smaller. The good thing about these two equations is they line up perfectly with each other. So if I write them on top of each other, which I'm about to do, I can see that they're all lined up. What we don't have is opposites. But I do notice that there's a 2j and a 2j. So all I have to do to make them opposites is multiply one of them by -1. So now I have negative 2j minus 2h equals -12, and 2j plus 6h equals 28. I add the two equations together. I get 4h equals 16, h equals 4. I look at my choices, and there's two possibilities, so I have to keep going. So now I take one of those original equations. I'm going to do 2j plus 2h, but I'm going to place the h with a 4, equals 12. And when I solve that, I get j equals 2. So that would be choice C. I'm going to clear the screen. So if you want all this, just pause it, or go rewind and pause it so you can write it all down. So the reason I'm clearing it, I want to show you the test taking strategy. So let's say I want to try the choices out, and I'm going to try out choice C, which I know is correct. But so it says J is 2. I'm going to replace that with a 2, and H is 4. So that would be 6, 6, 4, and I add those up. 4 plus 6, 4 plus 6, and it all comes out to 20. On this one, I replace the J with the 2. So that would be 3. I replace the h with a 4, so that would be 12. 3 plus 12 plus 3 plus 12 is 30. These are the correct numbers, so that's the answer. That's how you would use the choices to your advantage. That's something you should get used to for when you take the Regents in high school, or when you take the SAT, or really any test. Use the choices to your advantage. And by doing a bunch of practice tests over and over again, you kind of get to see what kind of choices that test makers like to put, and you get used to it, and it helps you. All right, here we go. Line N is shown on the grid below. Line Q is going to be graphed on the same grid. We don't know what line Q is. Line Q could be any of these. But it says the only solution to the system of linear equations formed will be at 3/2, which, if you wanted to see that as a decimal, is 1.5, and y equals 0. So the only solution is going to be 1.5 and 0. So if I look at a graph, 1.5 and 0 is right here. Hopefully you can see it, that blue blob I just drew. That's going to be the solution. Now, I have 4 possible choices. So I'm just going to graph each one until it goes through that point. And then I'll show you another way to do this. So the first one, y equals 3/2x, that starts at the origin. I'm going to graph it in red. And we're trying to go through that blue point. And since it's the slope is 3/2, I go up 3/2, up 3/2. And when I draw it, I see that it does not go through that blue point. So that is not the answer. A lot of you picked that one because you saw the 3/2, but Okay, the second choice, y equals 4 over 3x minus 2. So you start at negative 2, and you go up 4 over 3. That goes here, here, and here. I do my best to draw a straight line, and look at that. It went right through that point. So B is the correct answer. Y equals 4 over 3x minus 2. So let me show you another way you could do it. You could write down the equation of line n. So here's line n. You need a slope and a y-intercept. Well, you can see that the slope is down 2 over 3. So negative 2 over 3x. And it goes through 1, so plus 1. And now you can just use that to solve each one of those choices algebraically and see which one's right. So if we have this equation and this one, since they're both y equals, I can set them equal to each other. And now I'm going to solve this, so plus 2 over 3x to both sides. We get 1 equals 2x minus 2, add 2. So that's 3 equals 2x, and then divide by 2. X equals 3 over 2, which is what they told us here. But I think the easiest way was to just graph each of these lines and just see when it goes through that point. Okay, so this one says solve it using substitution. Remember that substitution is when you take the information from one question, from one equation, and you substitute it into the other one, like so. Also remember that if both equations are in slope-intercept form, meaning y equals, you can just set them equal to each other. And then you just solve this, plus 3x to both sides. Negative 13 equals 8x plus 3, minus 3 from both sides. Negative 16 equals 8x. Divide by 8, x equals negative 2. Plug that back into both equations just to be safe. If you only plug it into one, that's, it's taking the lazy way out because you don't know if it's right or wrong. Negative 10 plus 3 is negative 7. 6 minus 13 is negative 7. So the answer is negative 2, negative 7. Okay, hope this video helped. I know it went a little longer than I had planned, but that's okay. If you're watching it, and I hope you are, I know Miss Onesto's class is. Shout out to Miss Onesto's class. You can pause, you can fast forward, you can rewind, only look at the questions you need. Reach out to your teachers with help. We would be happy to go live with a group, with one, with whoever. Just ask for help. We'll help you. Let's get ready for high school. Hope everyone's doing well and staying safe and healthy. I know the weather's getting nice, so be smart about things. Have a good day.